Hello grade 12s, welcome to grade 12 trigonometry. Yesterday we spent time revising grade 11 trig, and today we're moving on to the first concept we need to cover for grade 12, that being compound angles. Now, true to the definition of the word compound, a compound angle will involve a trig ratio with the sum or difference of two angles. This implies that any angle can be broken up into a compound angle form. For example, you could break up sine of 3 theta into sine of 1 theta plus 2 theta, and then you can apply an identity that we're going to go over now. Now these are the four. Well, the first one is cos A plus B can be broken down into cos A times cos B minus sine A sine B. Let me get my pointer quickly. There we go. So note that cos A plus B becomes a minus in the middle. You do get these identities on your formula sheet, but obviously if you memorize them, you'll save yourself some time and you'll improve on your confidence in knowing your stuff. Also, the proof of these identities does not need to be memorized for final exams, but so I'm saving time by not even going over the proofs. I'm just going straight into the rules themselves. But if you do want to have a look at the proof, it's on page 131 of the Mindborn textbook. Right, so cos A plus B, any two angles can be broken down into cos A, the first angle, times cos the second angle, minus sine of the first angle, sine of the second angle. So then if you get a difference between two angles, then the sign on the right-hand side of the equation just changes. So cos A minus B becomes cos A times cos B plus sine A times sine B. Then for sine, so notice how cos, for the cos compound angle identities, you have your coses together, and then you have your sines together, separated by a plus or minus in the middle. So it's always cos, cos, sine, sine. When you see a cos, cos, a sine, sine together, you know you somehow need to apply the compound angle identity for cos. Next up, we get sine's compound angle identity. A plus B will become sine cos. So sine of A, cos of B. The sign inside this bracket stays the same, plus cos of A, sine of B. So for the sine identity, we have sine and cos together, sine and cos together on the other side of the plus sign, with the A and B respectively. And you guessed it, we're going to have sine A minus B, and that gives us sine and cos together, sine A cos B, and minus cos A sine B. So write these out, keep them nearby. This is your GPS map for this section, and I really, really want you to memorize them as much as I think I cut out there. I said I want you to memorize the identities, and if you can't have your information sheet nearby, you always. Righty, so now we're going to start with an example, and this example is asking us to expand the appropriate compound angle identity. So that means, expand using the appropriate. So if we are given a compound angle and we can see that we've got a sine compound angle, we've already narrowed it down to having to use the sine compound angle formulae, right? Since there's a plus in the middle, you go find the one where there's a plus in the middle as well. Okay, so that's what's popped up on the screen now, sine A plus B. But let's link up A and B to the angles that we've been given. So 2 alpha can be your A and 45 degrees can be your B. And we copy this format, we mimic it, and instead of writing A and B, we write 2 alpha and 45. Now let's just double check. Does 2 alpha link up with A? 45 is B. 2 alpha is A, 45 is B. So we've applied that identity to two angles that are not A and B, but it does fall into the same format, or does represent a compound angle. Now I'm going to be silent for 3 seconds for you to guess what is special about this line. Aha! You got it. 45 degrees is a special angle, so we can simplify this a little bit further. Instead of writing cos 45 and sine 45, we write down what that is equal to because we know our special angles, right? And then because cos and sine are cofunctions and 45 plus 45 gives you 90, that means they are equal at 45 degrees. So they both root 2 over 2, and now we have a common factor that we can factorize, which is a perfect way to leave this as our answer. If you wanted to put it all over 2, that would be perfectly fine as well. Easy peasy lemon squeezy. Oh, note, there are more examples on page 132. I really insist that you go and have a look at them because this video is covering the bare minimum in order to try and save recording time. So please can you go and look at page 132 and look at example A, 1, 2, 3 and B, 1. So example 2 is allowing us to use the compound angle identities backwards. So if we were to be given something that mimics the right-hand side of the identities that we've just covered, we can narrow it down and combine those angles to create a compound angle. So if you have a look, we've got a cos, sine, sine. When you see two coses together and two sines together, then you know you're using a cos compound angle. The minus in the middle should tell us that we're using a compound angle for cos with a plus inside its brackets. But you'll get used to that as you do the exercises. So let's link up the A's and the B's, and then that links up to this identity, cos A plus B. So you guessed it, we just write that this is equal to cos A plus B, 3 theta being A and 2 theta being B, and the sum of those two gives us 5 theta, just like that. Now I want you to try the next one by pausing the video before you see the answer. Use a scrap paper, whatever you can. It doesn't have to be neat and tidy. I know you're going to make lovely notes after this video, so please just give this one a go on your own. Sine 3 theta, cos theta, minus cos 3 theta, sine theta, and pause. Well done if you realized it was a sine compound angle identity with a minus and 3 theta minus. So now we're going to do an example that's slightly trickier, but still works using the compound angle identities. We need to calculate the value of the following without the use of a calculator. But if you have a look, at first you may think, oh, I'm just going to apply my identities. However, there is a problem. There are no two matching pairs. What do I mean by that? I see a cos 10 and I see a sine 10. Great, we've got a degree that repeats itself, an angle that repeats itself, so we have got one matching pair. But 160 is not the same as 110, so that cannot be linked up to one of our compound angle identities. Furthermore, we have a cos sine on the left-hand side of the minus sign, but then a sine sign on the right-hand side of the minus sign. So this does not link up to a compound angle identity. Therefore, we're going to have to manipulate this question using our cast diagram. That is the cast diagram. And since we are happy with cos 10 and sine 10, we're going to leave them alone for now and rather work on the two angles that differ from each other. 160 degrees is in quadrant 2, so we can rewrite 160 either as a 90 plus something or as a 180 minus something. And that something would be 20 degrees for the sake of 180 minus. Or you could write 160 as 90 plus 70. For now, that's all you need to do. Don't overthink anything. Don't make too many moves too soon in trigonometry. That is my number one piece of advice. I will repeat this. Don't try do too much too soon. Let the options reveal themselves before you make decisions. So now let's work on sine of 110. 110 is also in quadrant 2, so we can rewrite 110 as 180 minus 70, or we can say 110 is 90 plus 20. Once you've listed these options, you must choose one option from each of those scenarios, from each of those rectangles. The rule is, though, whatever option you choose in the pink rectangle at the top, you must choose that same option in the blue rectangle down below. What do I mean by options? Well, you're either going to reduce your trig ratio to be in terms of a 20 degree or a 70 degree. If you choose the 20 degree option in the pink rectangle, you must choose the 20 degree option in the blue rectangle. That's what I've chosen to do. If you choose to use the 70 degree option, how incredible, you'll end up with the same answer. That's what's so fascinating about trigonometry. But for now, let's follow through with the 20 degrees. So I'm going to reduce sine 160 to actually just become sine of 20 degrees because it's in quadrant 2. And then I'm going to apply the COCO rule, the co-function formula, and change my sine of 90 plus 20 to cos of 20. It's positive in quadrant 2 because sine was positive in quadrant 2. Now we just apply this to our question. Everything that's been written thus far is merely working out. The question can now be replaced. Now this white rectangle is what is crucial to write down. Instead of 160, we now write down sine 20 degrees. We kept the cos 10 degrees, we've kept the sine 10 degrees, but we've replaced our sine 110 degrees with cos of 20 degrees. Now it should be quite obvious. We've got a cos sine on the left-hand side of the minus sign, and then we've got a sine cos on the right-hand side. With mere manipulation in terms of being able to multiply in any order, we can swap over the cos 10 and the sine 20 in order to apply the sine compound angle identity, A minus B. 20 degrees represents A, 10 degrees represents B, so we can say sine of 20 degrees minus 10 degrees gives us sine 10. Woohoo! We have now calculated the value. I just want to see I don't like the way this question has been worded, and I've just realized now I copied this from the textbook, but this question should rather say write the following in terms of one trig ratio. I'm not going to undo it. Just listen to what I say. So this question should rather say, write the following in terms of a single trigonometric ratio. Often, if we had to calculate the value of this, it would boil down to be sine of a special angle, and then we could find the value. But this case, it won't boil down to being a special angle. So in other words, the question should have said, write this expression in terms of one trig ratio. A single trig ratio. Sine 10 is one trig ratio. The end. Please go over page 133's examples. There are several more to look at, and then go and tackle exercise 4.2 as listed in the to-do list. Thank you.